I was inspired by a post I saw on X from Christos Zamos, where they ran Sudoku inside a transformer as a program. I took 3 blockchain validation rules: balance checking, double spend detection, and chain integrity, and compiled them into attention heads and multi-layer perceptron weights. No Python runs at inference. The logic is the geometry of the weight matrices. Sounds impossible? Let me show you what I've done so far. So here's a very quick overview of what I've done. Some of the flow around a transformer weights. So with the inputs, the embeds, multi-attention heads, multi-layer perceptrons, weights, multi-dimensional, just matrices of numbers. Ours are compiled, not learned. So the vocabulary, you can see the BOS and the vectors of Q, K, and V. So here we've got some validation rules. It compiles by the Tracr compiler. And then we've got the weight matrices, quite a few thousand parameters. And our 3 blockchain components, the balance, validator, double spend detector, and chain integrity is what we're sort of showcasing around. Here's the forward pass, so you can see some of that flow, and we get a balance valid or balance invalid. So we haven't trained any data, we're not calling in APIs, it's just compiled logic, we're just testing this, it's only ideation. So let me show you the notebook, the code in action. Okay, first of all, this first cell, we pull in our dependencies. The key one here is Tracr. That's Google's DeepMind compiler that turns RASP programs into real transformer weight matrices. Everything else is standard NumPy, Plotly for the 3D visualizations, and IPy widgets for the interactive controls. Let's run this cell, and that imports are ready. Okay, so now we go to the compilation cell. This is where the magic happens. Remember those weight matrices that I showed earlier, filling up with values? This is us creating those weights, not by training, but by compiling. Each validator is a RASP program that Tracr turns into actual transformer parameters. When this cell finishes, we have 3 working transformers with real weight matrices, no training data involved. Okay, so let's run this cell, and we can see that it is now compiled, balance validator, double spend detector, and our chain integrity. Now we define the actual blockchain data structures. Each block gets a SHA-256 hash, links to the previous block. Pretty standard blockchain stuff, but the validation is not standard. Validate block all function runs all 3 compiled transformers. Each one does a real forward pass through the weight matrices that we have just created. So let's run this cell so that we can move on to the next. Okay, so this cell is going to set up the interactive controls, so that when I click process block, it calls the validate block all function. That's 3 separate transformer forward passes running in sequence. The HTML output shows exactly what each validator saw and decided token by token. So we'll just go and generate a few blocks so that we can go to the next cells where we can start to see these in 3D, but we just need to generate some of the blocks. So that's looking good. And this cell allows us to see the blockchain in 3D. So once I run the cell, we'll be able to see the 3D representations of our blockchains and attention head and layers and dimensions. So here you can see 3 blocks that were created earlier. The view is better when it's smaller, but you can still sort of see, you can see the sort of block details, the hash, and it allows different views. So what I've done here, I created some more blocks and just done a refresh so that we can see more of those blocks in the chain forming. So, this starts to give you an insight of, what we really can do. It's looking really positive. Okay, and this cell, this is what's going to allow us to see the internals of the sort of transformer. So once we run that cell, we should be able to start to see 3D representations, from within that sort of forward pass pipeline. So as the embed, the attention, the multi-layer perceptrons, the unembeds. So here we're just looking inside, so we get that 3D residual stream plot. Just shows how each of the tokens vector representation evolves through every layer. Again, apologies for the view here. It's nicer when it's sort of a bit bigger, but you can start to see where we can sort of go with what we're doing here. Again, this is just early ideation, but we just start to see some of that sort of 3D representation of where we can go. So the attention sort of patterns here, our Q, K, and V vectors. From what I showed earlier, this is inside. So you can start to see those stacks, those layers. Okay, and in this cell, what would a chat interface sort of look like? So this is the really interesting bit. We can chat with these compiled transformers. So we can start to, once I run this cell, I'll show you what that chat interface looks like, and we can start to interact with sort of deposit, withdrawal, deposit, and we can see the streaming sort of back of those validation results, sort of token by token. So let's go to the chat interface here, and let's just do a DWDD so you can see those tokens streaming. And here we can check some orders. We can have disorder just to show that those sort of validations are sort of streaming back to us. I will do further videos where I sort of integrate sort of Claude or ChatGPT, other LLMs into this flow. Okay, and this last cell is just a quick one. It's sort of a precursor to a future video where I'm going to sort of show some of the data sort of viewable in the sort of positron IDE, but I wanted to quickly show you some of that matplotlib plots that can give us sort of a different view, but of the same data. So this is just a sneak peek to a sort of future video. I just wanted to quickly sort of share, just to sort of put a towel on the end of this video, which we have now come to. Okay, so that's the end of another video. I hope you enjoyed that. Maybe you found it of inspiration. But let's just quickly step back over what we've just done. So we compiled blockchain validation rules, balance checks, double spend detection, chain integrity, and place them directly into transformer weights. No training loop, no loss function. The weights are the program. Now, is this production ready? No. This is ideation only, pure curiosity. This is me playing around, seeing what's possible. Being inspired from Christos's sort of expo. So again, have a look in the description, go check the post out, and you'll see something much, much better than what I've just shown here. But here's the thing that keeps sort of getting to me. If you could compile a blockchain into a few thousand parameters, what else could you compile? As LLMs get bigger, as interpretability research matures, we might start finding that models are already doing this, embedding small computational programs inside their weights as a side effect of training. We just haven't learned to read them yet. Anyway, that's the rabbit hole. That's for another time. As always, I genuinely appreciate your time. So whatever you're doing today, whatever you're doing this evening, have a great day, have a great evening, and hopefully see you on the next video.